Okay, we're moving on to Unit 7 now. I'll go back and take the Unit 6 test next week, but because Unit 5. We're going backtrack into Unit 5. We went from 4 to 6, now we're back to 5.1. You gotta determine that first off, it shouldn't say range, it should say rate. Rate of change is constant. If it is, find the rate of change with the label, okay? Now here's what a rate of change is, okay? It's the miles every single minute. So what you're going to do is make a little thing right here. You're going to put miles, and again, this is X, this is Y, okay? It goes X, Y table. So you're going to put your Y over your X. Your Y's got to be on top, miles per minute. So just miles and then minute. Don't put an S on minute, okay? Now here's how you determine this. There's 3 steps you have to take because you went from here to here, here to here, here to here. That's 3 steps, so I make 3 ratio lines, okay? And then I also go here from here, here, there, there, there. Now to find out what it's changing by, we actually start at the bottom and minus. So 21 minus 15 is 6, positive 6. 15 minus 12 is 3. 12 minus 6 is 6. Okay, now with that being said, in the meantime, this is 4 minus 3 is 1, 3 minus 2 is 1, 2 minus 1 is 1. So what you're going to do is take the miles that it changed by, and then the minutes, miles, minutes. So on this first one, okay, we have, actually let's just go to the bottom, okay, 6 miles over 1 minute. 3 miles over 1 minute. You're going to want to put your labels, okay? Then 12 minus 6, 6 miles over 1 minute. Now you're going to divide those and see if they're all the same, okay? So 6 divided by 1 is 6. That's 3, that's 6. They were not all the same. So what you write next to your miles minute is not constant. It's not a constant rate, okay? That is not constant. So not constant. Now if they're all the same, let's say they were all 6, you put a 6 in front of that. Okay, pencils. Pencils is X, money's Y. So again, I want to find the cost, the Y, the dollars per pencil. Put it in singular form though. Okay, so here's how we're going to find the cost per pencil, because see, we don't know because it jumps from 1 to 4 to 7 to 12. Okay, so again, you make 3 jumps. 1, 2, 3. That's 1 jump, 2 jumps, 3 jumps. Okay, so first off, and again, we want to be taking our dollars and our pencils, okay? So 3 minus $1.75 is $1.25. In the meantime, 12 minus 7 is 5. So that's $1.25 for 5 pencils. The cost went up $1.25 from buying 5 pencils. Now take your $1.75 minus 1, that's 75 cents. And then 7 minus 4 is 3. So that's going to be 75 cents, okay, from buying 3 pencils. And then finally, okay, $1 minus 25 cents is 75 cents again, and then 4 minus 1 is 3. Okay, now divide all those. Well, these are going to be the same, obviously. So $1.25 divided by 5 is 0.25. Okay. 75 cents divided by 3 is 0.25. And then that's going to be 0.25. So it's constant. Okay. So the constant rate is 25 cents per pencil. Okay. Now what that means is, I know, because this jumps, you know, it doesn't go from 1, 2, 3, 4. So that means you don't have to do this, you can just watch. But that means if you bought a 13th pencil, this would go up by 0.25. So it'd be $3.25. You bought a 14th pencil, the cost would go up by 0.25. So basically, we've done those tables on story problems before. You're essentially finding what you would add every time that increases by 1. Okay, so 25 cents per pencil. That's a 0.25. Okay, then our last one. So that's X, that's Y. Now on your labels, you're going to put feet. It's always y over x, feet per minute, singular form. So again, 3 jumps. So 24,000 minus 27,500, you start at the bottom. Now you need to put the negative 3,500 feet. And then I jump over here, 12 minus 5 is 7 minutes, okay? Okay, remember it's the y over the x. And then 27,500 minus 29,000, negative 1,500. Sorry, I forgot to label, negative 3,500, okay? Then 5 minus 2 is 3. Okay, then last feet minutes. So the change here, 29,000 minus 30,000 is negative 1,000. And then 2 minus 0 is 2. Okay. Okay, now the reason you got negative is because what happens from here to here? It goes down. Here to here, down 1,500, down 3,500. That's why I usually work my way from the bottom up to find what it's changing by. Up 2, up 3, up 5, up 7. Excuse me. Up 2, up 3, up 7. Okay, divide them. See if you get the same thing. So negative 3,500 divided by 7. Negative 500. Negative 1,500 divided by 3. Negative 500. Then negative 1,000 divided by 2, negative 500. So it's constant, okay? And you put negative 500 next to that. Okay, and again, that's your answer. Just watch on the next one. So what that means is if this went by 1, so like 13, 14, I'd add negative 500 every time that goes up by a minute. So that's going to be 24,000, because that would go down if you're adding negative 23,500, 23,000, and so forth. Obviously, it would stop when you got down to 0. Okay, so you can have negatives. Okay. All right, now you're going to learn a new concept here. Find the slope of the line. Okay, this is a line. Graph for me. I don't need to graph it. A slope is rise over run. It's a ratio. Okay, rise over run. Now, this is how you find the rise run. You see the 2 points. Put an L for left. What point is closest to the left? It'd be this one. Label that point number 1. And this is point number 2. You start at point number 1 and you move up or down first. You have to do that first, okay? So you'd have to move up, straight up or straight down. So if I'm starting at point 1 to get this point, I have to go straight up first. And then count as you're doing it. Now if you're moving up, you count by positives. So 1, 2, 3. So positive 3. That's your rise. And then your run is forward. 1, 2, 3, 4. Okay, 3/4 is the slope. Now this is in simplest form. You can't reduce 3 and 4. Okay, 3. You want to reduce it if you can, but see on a multiplication table, 3 and 4 are just multiples of 1, so it's stupid to divide them both by 1 because they'd just be the same. Okay, next one. Left. So this point's closest to the left, and then that's 2. So rise over run. That's a slope. Okay. Okay, so you start at point 1. You move straight up or straight down. We'd have to move straight down. Now you count by negatives as you're doing that. Negative 1, negative 2, negative 3, negative 4, negative 5. So negative 5 is your rise. Then your run is 1, 2. Okay, now, so you have negative 5 over 2. Now, can you reduce 5 and 2? Do those have any common factors that you can really divide by? No, because on a multiplication table, they're just both in the first row. So, simplest form. By the way, here's what I'm talking about by that. Don't write this down. But if you end up with like, I don't know, 6 over 10, those are both in the second row on a multiplication table, so those can be divided by 2. So in simplest form, it'd be 3/5. Okay, next one. Left, okay? So this is point 1, this is point 2, okay? So, rise over run. So you start at point 1, you go up 2, so 1, 2. Positive because you went up. Then 1, and you always count by positives because you're going forward. You're always going to be going forward. 1, 2, 3, 4, 5. So it's 2 over 5. Now 5 over 2 couldn't be simplified, neither can 2 over 5. That's your slope of the line, okay? And here's kind of how a slope works, because if you go up 2, 1, 2, 3, 4, 5, you're on the line. Up 2, 1, 2, 3, 4, 5, there's the line, okay? So every time the line goes forward 5, it rises 2. Okay, next one, rise over run. So left. All right, so that's point 1 and that's point 2. Okay. So first off, you'd move down. So -1, -2, -3, -4. So you count by negatives when you're moving down. So the rise is -4. Now the run, 1, 2, 3, 4, 5. Okay, so -4 over 5 is the slope. Now, can you reduce 4 over 5? I don't think you can. They're just in the first row, so that's in simplest form. There is a problem where you're going to get, and here's another example of reducing. So 6 over 3, okay? Those would both be in the third row, so we could divide them both by 3, and that would be 2 over 1. I want to see the 1, okay? Because that's your rise, that's your run. I just made that up.